Johannes Kepler, born on December 27, 1571, and he died on November 15, 1630. He is a German astronomer who discovered the three major laws of planetary motion.
At the turn of 16,000, the way in which solar system and the universe as the whole was viewed began to change with the controversial conclusion of Copernicus. Scientists already began to adopt the idea of solar system.
The three planetary laws developed by Kepler with the data gathered by Brahe shaped the way in which science viewed the structure and motion of the planets of the solar system in profound ways lasting to this day.
The idea that Kepler sought most in his dealing with astronomy was theorem that would have the capacity to predict where a planetary body would be at a particular time, and the key to solve this problem is finding the relationship between the different velocities of a planet as it travels its orbit.
The planet moves an elliptical orbit with the sun of focus to the time necessary to any arc of planetary orbit is proportional to the area of the sector between the central body and that arc, the area low, and there is an exact relationship between the square of the planet periodic times and that cubes of the orbits, the harmonic law.
Kepler himself did not call these discoveries laws, as would become customary after Isaac Newton derived them from a new and quite different set of general physical principles. He regarded them as celestial harmonies that reflected God's design for the universe.
Discovery turned Nicolaus Copernicus' sun-centered system into a dynamic universe, with the sun actively pushing the planet around a non-circular orbit, and it was Kepler's motion of physical astronomy that fixed a new problematic for other important 17th century world system builders. The most famous of whom was Newton's second law.
Kepler's second law states that a planet moves in its ellipse so that the line between it and the sun placed at a focus sweeps out equal areas in equal times.
Good day everyone, my name is Christian Jerwin Fuego and I'm going to talk about Kepler's second law. Kepler's second law of planetary motion describes the speed of a planet traveling in an elliptical orbit around the sun. It states that a line between the sun and the planet sweeps equals area in equal times. Thus, the speed of the planet increases as it is near the sun and decreases as it recedes from the sun.
Kepler's second law, the radius vector from the sun to a planet swipe out equal to areas in equal periods of time. This means that it takes less time to cover and act close to the sun, so that planet must be moving faster, and more time to cover act further from the sun, so that planet be moving slower.
All the planets are driving by a force from their axis of rotation. In other words, although we know as this force to be gravity, but Kepler view it as a ray coming from the sun and acting of the planet as a paddle on the boat. In other words, Kepler's second law refers the law equal areas describing the speed at which any given planet will move while acting orbiting the sun with equal areas in equal length of time.
Importance of second law. Kepler's second law is valuable because it gives a quantitative statement about how fast the object will be moving at any point in its orbit. Note that when the planet is closest to the sun at perihelion, Kepler's second law says that it will be moving the fastest. When the planet is most distant from the sun, at aphelion, it will be moving the slowest.
The law of areas. Kepler says that if you draw a line from the sun to Mars and wait fixed amount of time, that line sweeps on its orbit as Mars moves along on its orbit. He noticed that This area was exactly the same no matter where the orbit you are, and also known as equal area and equal time law. The area swept out in fixed amount of time is the same.